Okay. So if you give one a push and then you let the other one fall freely, okay, the first one will drop before the second one because that the first one would accelerate more, acceleration, but not due to gravity. But the second one would free fall. Its acceleration would be due to gravity. Okay. So that is why I provided the acceleration of the second one. And then the other one, because it's free falling, will be due to gravity. Okay. So that's the whole what and what was missing from the question I forwarded to you. So give it a try. Okay. Give it a try and then you get back to me. So find the initial velocity of the second body. The second body would accelerate, but not due to gravity. The first one the first one accelerates due to gravity. Okay. And so in the first one, u is equal to 0. But in the second one, u wouldn't be equal to 0. That is why you are asked to calculate for the value of u. Please, any question? If you have any question, quickly ask and then any question. Gloria,
Mr. Ida, please, I didn't get the explanation to the question you were saying.
Gloria, this is what I'm saying. A boy, okay, on top of a 20-meter high cliff initially drops a stone. Okay, the first one free falling. 1 second later, okay, he throws down another. Okay, meaning that the earlier one was free falling. This second one isn't free falling because he applies a force to the stone to fall. But the question is saying that they all um, drop to the ground at the same time. Okay, they all drop to the ground at the same time. Now, when two bodies are let to fall freely, okay, no matter their masses, we expect them to fall at the same time, provided air resistance is neglected. Provided air resistance is neglected. Now, when um one stone is made to fall freely and the other one doesn't fall freely, but there is a force, the only time they can drop at the same time is when you delay one. That is why the question said 1 second later, a second stone is thrown. Okay, so the starting of the second one is delayed. However, it is not falling due to gravity, and um that also explains why they can fall at the same time and fall to the ground at the same time, even though one is thrown and the other one is made to fall freely. So the whole thing is that the other one, the first one would accelerate due to gravity. U is equal to 0. But the second one would accelerate not due to gravity. That's why I've provided its acceleration, 15 meter per second squared. Now use the information provided to calculate the initial velocity of the second stone. That is the explanation I gave earlier. Gloria, are you
Thank
okay?
you. Yes, please.
All right. So Akosia,
Mr. Ejia, so please, if you have a question, and let's say the boy dropped both stones at the same time, but one 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 of the stone hits the ground before the other. Does it mean air wasn't neglected?
no,
Air
Akosia,
resistance.
you are giving me two different scenarios. You are saying that the stones landed at the same time, and in other situations, you said landed earlier. Which is which?
No, he dropped the stones at the same time. but one landed before the other. So does
Yes.
it mean
Yes, in this case, it isn't a free fall. It isn't maybe one was released, okay, by throwing it, and the other one was let to fall. Because for free falling, we have to neglect air resistance. And I told you earlier that no matter their masses, if an object is free, is let to fall freely, they are all expected to drop at the same time, provided air resistance is neglected. Are you okay?
yes, yes, please. Thank you.
But when you throw them at the same time, and you throw one and you let the other one fall freely, one would certainly drop before another, the other mass.
Okay, thank you.
All right, please. Any more questions? Because our time is almost. I'm giving you the rest of the 7 minutes to look through the question, and please get back to me. Okay, give me feedback to the questions I give to the class. Are you girls okay?
Yes.
Sorry, are you all okay?
Yes.
Because we have 1 or 2 guys on the platform.
Yes, please.
All right. Okay. So this is where I draw the curtains on today's meeting. We'll have another good session tomorrow as well. Until then, please take care of yourself, revise, and then give me feedback. Bye-bye.
Bye. Please, I thought you have not found the answer. Or
Come again.
The
answer for the
Zubia, reposition. Your line is breaking.
Please, I'm trying to say initially we were solving, so the answer.
Oh no, I was giving you the tidbit as to how to go about it. Okay.
Okay.
So you solve it, and then Yaba, let me have your feedback. Let me get the response of this word. Yaba. All right. So that's it. So Zubia, I'll just do it and then get back to me. Okay.
Okay, sir.
All right. Okay. All right.